Standard disclaimer, I am not an expert. Do this at your own risk. Please educate yourself and do research and don't just follow someone blindly. I haven't even powered this on to test. So hopefully before I post this video, I will have tested it to make sure that I've got everything wired up right and it works. Although I am fairly certain that I do. So what I've done today is I've wired up the relay that goes to the foot motors. So that's this box here that has 6 connections to it. So briefly going over what this is. This relay and this wire that's flopping here will eventually be zip tied there. These are just on loosely. I haven't tightened everything up and finalized everything here with zip ties. But basically what you've got here is I've got a double pole single throw relay. What that means is this relay, as all relays do, has a coil right here that when you put voltage, positive and negative, across the coil, it makes an electromagnet that pulls a lever that switches a contact on or off, or multiple contacts on or off. So double pole means that this relay can handle 2 different connections. This is one connection. This is another connection. So this would be left foot, this would be right foot, or vice versa, whichever way you wire it up. So what this relay does is when this is a 24 volt DC relay, which means that this coil works off of 24 volts DC at a low amperage, so that when you put positive and negative to this coil, it becomes an electromagnet and switches these contacts. Dual pole, 2 contacts, so it switches them both at the same time. I have a snubber diode, also called a flyback diode in there, IN4004 diode, with the band, the white band, facing the positive voltage input to this coil. And here's a part I was confused about. Is this coil, does it want positive here, positive here? It doesn't say. It has a little just diagram, little picture there, and it labels the lugs 0 and 1, but it doesn't say positive or negative. So I was confused about that and had to do some more research and discovered that it doesn't matter if you put, in this relay at least, there's many types of relays, it doesn't matter where the positive and the negative is. What does matter though is if you use the snubber flyback type diode to protect this when you turn this off, when you power off your droid and power is disconnected from this electromagnet that activates with power. When you turn the power off, it can backfeed electricity into your electronics. So this diode will prevent that from happening, but you have to make sure that the band on it is facing your positive wire. So I could have put the positive wire over here, but then I would have had to solder this diode in the other direction so the white band was facing positive. So I chose to do it this way just because my positive 24 volts is right here. I am going into this XT60 connector, which I will have 2 wires coming out the other side going to a switch. You don't have to do that, but I'll explain why in a minute. So basically, there's a switch that will connect these 2 wires when it's turned on, which means 24 volts will go to this lug of the relay. This lug of the relay goes to a ground bus. So now this coil, if you forget about the fact that there's a switch here and just pretend like these are connected, so 24 volts and ground, when you turn on your droid, this coil will energize. And what it does, there's a diagram here. Now this relay comes in single throw or double throw, as well as double pole. So double pole, remember, is left leg, right leg. Double throw indicates how many lugs there are here. If you see this diagram, it shows 3 connections, but you can see I've only got 2. That's because this also comes in a configuration with 3 on each side, and that would be double throw. This is single throw. So the difference there, if you can see it here, this last set of connections that's missing from this relay, there's dashed lines there, which is indicating that's not present on this relay. So what this relay does is when this is energized, I'm sorry, this wire is in the way. When your droid is powered, 24 volts is going through this coil. The connections here labeled 2 and 4, and what is that? It's upside down. 6 and 8. Those connections are engaged. With no power, you can see how they're not touching. There's a gap. That's what this does when there's no power. These 2 wires, if you put your multimeter on these 2 wires, or the 2 metal lugs underneath there, there's no continuity between those 2 connections. They are open. There's a electrical gap, so these are not connected. So this wire does not contact this wire until you energize this, and then it throws that switch down to here to make contact, so then these 2 are making contact internally in the relay. So single throw is these 2 make contact when you power the relay. When you cut power to the relay, turn off your droid main power, this connection is broken, and these do not connect to each other. If it was a double throw relay, there'd be another lug here, like this diagram, but instead of a dashed line at the top there, what happens with a double throw is when there's no power to this center wire and this top lug, if you put a wire there, they would be connected. Then when you power the droid on, that switches over to here, so the center lug and this far lug are connected, and this one is not connected anymore. So single throw just means these 2 are connected or they're not. Double throw means these 2 are connected or these 2 are connected. Which, like I said, this relay doesn't even have a lug there, so this is single throw only. And that's perfect because that's what I want. I want a right leg, left leg connection. I don't care about another connection because I wouldn't want, when I power it off, it wouldn't really matter. This wire would not be connected to this wire, which is what I want. It would be connected to this other lug, which I could just leave alone, and it would still work. So you could use double pole, double throw. You just don't need to because you're only using single throw. So I hope I explained that well enough to get it. So what is my wiring actually doing here? What we've got here is a connector to one of the legs. Now, I've used red and black wires, but remember that the motors, when you drive R2 forward, the polarity is going one way with a positive and a negative, but when you drive R2 backwards, it reverses, the motor controller reverses the polarity going to the motor. So this would be positive and this would be negative. So I could have used, like I did for the dome motor here, just 2 red lines, 2 black lines, 2 blue lines, 2 yellow lines, red and black. Don't let that throw you off that this is positive and negative to the leg, because it depends on what direction your droid is going and what current that the motor controller is sending through these wires. So red and black, you don't have to think positive, negative. But what you do have to know is the motor has two wires. You're making a circuit, so you need to send current down to the motor, and it has to come back to complete the circuit. So I've got two connections here that go to wires that go through the leg and then connect to the foot motors. So this is one foot motor, and this is the other foot motor. So I've got my two wires. So one of them, I chose this black one here, goes directly to the Sabertooth. And I can't remember without flipping it upside down here, if this is motor 1 or motor 2. But let's just say this is M1A on the Sabertooth. Motor 1, wire A. This on the Sabertooth would be motor 1, wire B. So A and B on motor 1, that completes the circuit. So what I want is when I turn power off to my droid, I don't want that circuit active, because then if you push R2 with the battery out, the motors will generate electricity, it'll go into the Sabertooth and can damage it. So you want to make this no longer a circuit between the motor and the motor controller when your power is off. So that's what I'm doing by having this line, say M1A, going to the first motor, and it's always connected. It's always connected to that motor. This wire, M1B, is going to, in this case, here. One leg of the relay. The other leg of this relay is going to M1B on the Sabertooth. So this wire goes directly to the Sabertooth to M1A. This wire goes to M1B on the Sabertooth, but to get there, it goes into the relay, out of the relay, to M1B on the Sabertooth. So when the Sabertooth tries to send a current to motor 1, it has to go through this wire, into here, down to the motor, and then back from the motor on the black wire to the other motor 1 connector. So you've got your circuit. When the droid is energized, these are connected. So it's just like this. Ignore the connectors and think this is just one wire. So your black wire goes to M1A on the Sabertooth, and this red wire goes to M1B on the Sabertooth. When you power off your droid, the relay disconnects these two wires. So when the droid has no power, now you do not have a circuit anymore from the Sabertooth to the motor, because the black wire still goes to the motor, but this red wire, because you need the two wires to make the circuit, comes up from the leg, goes to this leg of the relay, and that's where it stops. It doesn't continue on to the Sabertooth. When there's no power to this relay, this connection is open, not closed. Same thing with the other leg. This black wire goes to M2A. This red wire goes to this side of the double pole relay, right and left foot. And then this goes to the Sabertooth, to the motor 2B. So same thing over here. If there's power, 24 volts going to this relay, both of these are connected and these are connected. So this goes down to the foot, it comes back up, it's connected inside the relay and goes to the Sabertooth. The black line is always connected to the Sabertooth, so now you have a full circuit of current. Power the droid off. These connections are both open. This connection from the foot motor does not go past the relay and get back to the Sabertooth, so it can't damage it if you push your droid. So that alone is pretty good. That alone means if you turn off your droid, you can push it. If your droid is turned on, you can push it because the motor controller handles the current that would come from the motors if you're pushing it and into the motor controller, and the motor controller will send it back to the battery through the 2 power lines that power the Sabertooth. So with this in place, you can push your droid anytime you want, whether the battery's in or out, because if the battery is out, there's no power. These are not connected. If the battery's in and the droid's turned off, you can still push it because these are not connected. If the droid is turned on, this will be energized. These will be connected, so you can drive R2 or you can push R2, and there's always a connection from here to the battery. So basics, that's all you need to do. The next step is a switch. I wanted a switch. So all you have to do for that is leave your negative wire hooked up, but take your positive wire that needs the 24 volts and send it down to a switch. When that switch is off, these 2 wires are not connected. 24 volts goes to the switch. It does not come back up here. So what that's good for is, say you have your droid at a convention or your house or at a friend's or whatever, and you want the lights to blink, and maybe the control system you're using has an automation mode, which a lot of them do, where the droid will sit there, randomly spin his head, randomly make beep boop noises, and the lights in the dome will flash. But you don't want it to drive away if somehow a signal interferes with whatever system you're using to control your R2 and it starts driving away. If you put a switch on this, it disconnects the power to the relay, so you can have the main power to your droid on, so everything in your droid is powered on. Flip this switch off, it breaks the 24 volt connection to the relay, so the relay has no power, so your foot motors are now disconnected from the Sabertooth, so you can flip that switch on your droid, leave your droid and run and get a drink, ask somebody to watch your droid for you, and your droid will not have any chance of somebody bumping your controller, or if you have your controller in your pocket and you bump it, it's not going to drive away because there's no connection to the motors. But the droid can still sit there with lights on and dome movement if you've got it set up to do that. And if somebody comes by from the convention and says, hey, you know, we need to move all this stuff back 3 feet to make this aisle wider, this droid could be pushed because there's no connection between the Sabertooth and the foot motors. So you can push it. Even if it was turned on, you could still push it because there would be a connection and a battery. So it's the best of 2 worlds, because instead of just having power on and your feet work, power off and your feet are separated, you've now got the option to power the droid on and just cut the feet and just do it with 1 switch. Not a left foot and a right foot switch, just 1 switch, because this relay is a double pole. It has 2 poles. It's controlling left foot and right foot in 1 relay. So again, hopefully that makes sense. Now, if I show up here, this is Darren Poulson's website. If you search Google for R2D2 relay, this is like one of the first hits. And this is where I got most of my information. He has a link to a 24 volt and 12 volt relay that he says use something like this. He doesn't say that's exactly what he used. His comments also say he used a double pole dual throw, which I questioned him about to make sure before I wired mine that I understood, because if you look at his wiring diagram, if you can see the mouse here, he's not using a double throw on this relay. It has double throw, so when there's no power, these two lugs are connected. When there is power, these two lugs are connected. But he doesn't have anything on these lugs. So this will work. It just has two connections that aren't being used. And I asked him about it, and he said that the reason that he did that was because at the time that he built his system, it was easier to find the dual throw than it was the single throw. That's like, okay, that's what I figured, but I wasn't sure. I wanted to make sure that, because there's so much information about relays that I wanted to make sure, why did he use that if he didn't have to, because he's not using these lugs. And it was a simple supply issue, so it makes perfect sense. But here on his site, you can see the same thing that I just talked about. He's got the battery, so you've got this relay that I have is 24 volt relay. So this coil is powered by 24 volts DC. So you've got your 24 volts from your batteries going into and a ground coming out of the coil to energize the coil when your droid's turned on. And then he shows the connections and the Sabertooth connection. So motor 1A, motor 1B. Then it shows what you connect. So that's what I just talked about. And then down below, he goes further and he shows a switch. So same thing that I did. You can add the switch. And so now, if your droid is powered on, the relay's powered, or you can leave the droid turned on and flip that switch and the relay powers off, so your droid is all turned on except for the foot motors. So there's no chance of it rolling away on its own, and it can still be pushed and it won't damage the Sabertooth. And then he goes on and has another diagram, which is pretty cool, which is adding it controlled by, say, your Arduino, like a failsafe. So with this setup, which I don't fully understand, but say you've got your Arduino that sends a signal through a resistor and then the diode and another diode to the relay. You can basically set up a button on your controller, or you can get like a remote key fob thing that sends a signal, and you can send a signal to remotely turn off the relay. And so that would be what he does, is if he's driving his R2 around and then he gets to a place where he's just parking the R2, he'll turn off the relay. So now it's basically parked. It's like the emergency brake is on. There's no power to the feet, so it only gets turned on when it actually needs to move. One partial reason for that is relays do draw a small amount of power. So if you've got your droid parked and it's going to sit there for a couple hours and not move, and you have a relay, it is going to draw some power from your system, keeping that circuit, that magnet engaged, keeping those contacts made. So if you remotely have an easy way to switch it off, then your droid will just sit there, the motors won't be connected, and it won't be drawing any excess power because you're not driving it. Then when you want to drive it, you just use whatever, either the switch like I have, the upper diagram, or you set up some remote system to trigger that relay to turn it back on the next time you want to drive. So definitely recommend, and I'll put a link, you look at Darren Poulson's blog about his relay. The one thing is, reading the data sheet on these relays got me really confused, because the data sheets are for multiple versions of the relays, AC and DC. And one thing that I'm not pleased with the relay is if you look at this, 24 volt DC coil, 30 amp switching current, dual pole, single throw. Okay, this is the one I got. Single throw, because there's 2 lugs for each pole. 3 lugs would be double pole, double throw. So I got the single throw because that's all you need. If you look at the data sheet, and if you actually look at the, I don't know if we'll be able to see, it's probably too small. If you look at the fine print on the actual relay, it is a 24 volt DC coil. So the coil is 24 volts. And if you look at the ratings, it says 30 amps. It'll handle 30 amps at 277 volts AC, 20 amps at 28 volts DC, 1 horsepower at 120 volts AC, 3 horsepower, and then a couple other measurements. So at the top, I was a little bit disappointed because, and this is my fault, it says 30 amp, 24 volt, 30 amp, and I thought that what I was buying was 24 volt, 30 amp, but the way I read this, it's 20 amp at 20. The 24 volts is just what it takes to activate the coil. What these lugs can handle is 20 amps at 28 volts DC. So with my system, I've got 2 12 volt batteries in series, and they create fully charged about 27 volts. So basically the relay, this relay, the one that I purchased, is 20 amps in my application. So each of these lugs can handle a maximum of 20 amps. So yeah, that's where I'm kind of, I wish it was 30 for the comfort of knowing that it's definitely more than it's going to receive. My Sabertooth is the 2x25, which is 2 motors at 25 amps. So I would be happier if this was 30, so it would handle more than the maximum that the Sabertooth can handle, which actually I understand the Sabertooth can handle peaks above the 25 or the 32 if you buy the 2x32 Sabertooth. But yeah, I think that'll be okay. You know, it's another, see, this is why it's so complicated. Your foot motors have like an average current draw that they'll use, and then they have a stall current, which is if, say, rocks got stuck in your wheels and you're pushing full speed ahead on your controller and the motors are trying to go full speed ahead, but they're jammed due to some reason, it can shoot way up. So I'm not exactly sure how high the draw can get on the foot motors, so I'm thinking the 30 amp I would have been perfectly safe, but my motors are 100 watt 24 volt, and I'm hoping that 20 amps per is enough. I'm pretty sure it is, but I would have liked 30. So it's another thing that you need to research when you do this, is make sure you understand all of that, and there's a lot to understand, which is why, you know, disclaimer, this is my experience. And hopefully I explain things to the point where this helps some people and you can maybe understand a relay, how it works, and why it's a beneficial thing to have. Although, again, it's not necessary. I thought that it would be a really nice safety feature that basically with this relay, I do not have to worry about pushing my droid, whether it's powered on, powered off or not, whether the batteries are in, batteries are out. I don't have to worry, and I have an additional feature that I can let the entire droid be powered, except the foot motors, if I want to save the power that this relay is using when the droid's not moving anywhere, and if I want to make sure that the droid is disabled and will not drive away on its own for any reason, because the motors are physically not able to be connected to any current, so it would not be able to move at all, even if you push on your controllers telling it to move, until you switch that switch back on again, and then you can drive it again. So hopefully this makes some sense and might help somebody. I think I went over most of the points that confused the heck out of me, but again, try to do your research. look into this stuff a lot. It took me, it's taken me a couple weeks of looking on forum posts on Astromech and videos on YouTube of how relays work. And in the end, I had to send an email to someone to say, okay, I like your diagram and I understand it except for a couple things. And that's where he cleared up the fact that you only need the single throw relay. And this particular relay, it doesn't matter if positive or negative is going to the switch. In fact, different relays will have different diagrams here. This is again a diagram. This relay has one switched connection for each pole, and this is the symbol for the relay, that it has a relay on it. So there you go. Hope that helps somebody. Okay, baby steps here. What I've got now is I have my battery set up, going to my main breaker power switch, goes into my electronics board. I have the positive lead of both the Sabertooth and the Siren motor controllers not connected to anything, so they won't get power. What will get power with this setup is the voltage converter. We'll get 24 volts and put 5 volts out to this fuse block, which has nothing connected other than the meter. And this is the back of the board, so the front of the board right over here has the meter that says 5 volts and 24 volts. So those are powered on. And then I left the amplifier powered on, which is coming from here. And also the 24 volts that's going to this connector, which will go to the dome to provide 24 volts to the dome, where it gets regulated to 5 volts. So the main thing I'm checking right now is this relay. I have wired this relay in place. I have wired it to the switch, like my previous video. And I've gone to a switch. This is a big honkin' switch that is way more powerful than it needs to be. Handles way more amps. I believe this is a 30 amp 12 volt DC switch that I got. So I think that means it's 15 amps at 24 volts. Way more than this relay uses. But I like the size, the tactile feel. I plan to put it underneath the skirt next to the main power switch, or near it, depending if there's even room to put that next to it. So all this test is, like I said, the amplifier will come on. It's not hooked up to speakers. It is hooked up to connectors that go to speakers, but there's no input to it and no output. All I want to do is know if I can hear the relay click, meaning that it works. So this is currently off, so the relay should not get power even though I turn the main power on. So I'll turn the main power on. Hopefully everything is okay. And then I'll turn the switch on, which unfortunately is kind of a loud switch, so I'm not sure if I'll be able to hear the relay over the sound of the switch switching. I could put, I can't even put a multimeter. Well, I could put a multimeter to test continuity between the wires with the relay on, because there won't be any voltage passing through these wires because they're not hooked up to anything. There'll be 24 volts here activating the relay, but nothing here, but these wires will be connected. But I'm hoping I can hear the relay switch on when I do this, so fingers crossed. So here's the main power switch. Okay, and here is the relay switch, which of course is going to be hard to do with one hand. And I heard the relay click. Awesome. The relay has clicked. Hopefully that came in on camera. I am about to turn it off now. It is a definite click. Definitely louder than the switch. My main power is off now, and I have successfully tested that this relay is switching. Now, yes, I admit I did not put a multimeter on each pair of lines to make sure that this connection is being made and that this connection is being made. I'm just taking it on faith that I can hear the relay clicking, that these with the relay off are not connected, which I have verified with the multimeter, and trusting that they are connected because I heard that sound. I could pull those leads part way off and check with the multimeter down near the relay, but I'm pretty confident that the sound of the relay switching means the relay works. So why did I do this with these wires unplugged? Because I blew up the electronics before, and as a YouTube commenter said, baby steps. So this is the baby step to checking the relay. All I have apart from the amplifier that's actually running is the voltage regulator and the relay. So I know my voltage regulator works because I already tested that. I know that the relay works because I've powered it on before. But this is the first time that I have put the relay in, wired it up, and turned it on. And I heard it click, so I'm calling that good. Things still to do. Obviously, I'll reconnect the Sabertooth and the Siren motor controllers. I have to hook up the Arduino, the MP3 player. They both go to fused 5 volts. I have to hook up a Arduino master. Again, fused 5 volts. So those things all need power, and power up to here, and then ground from one of the two grounds. And then I have to wire the signal wires from the Arduino to the Markduino, to the MP3 trigger, to the Siren, to the Sabertooth, not in that order that I just said it, but I need to put the rest of the boards on, basically run their power wires, run their signal wires, and then I need to take my R2 apart, bring the feed in here so I can hook them up, as well as the dome motor, to make sure that right is right, left is left, forward and backward are correct. And also I have to take him R2 apart anyway. This should be way longer cable than I need for this switch. So I need to figure out the final resting place of this switch and how long this cable needs to be so I can trim the cable to the right length, put the, these are just temporary crimp connectors. I'll put the nice shrink wrap or heat shrink connectors on. This will be mounted in the skirt. This, I printed a similar holder for this that I got off Thingiverse, just under toggle switch housing, I think I searched for. And there's several of them out there, so I've got one that looks similar to this that this switch will go into. So again, I'm not sure if there's enough room in the skirt for both switches, but I'd like to be able to reach underneath the skirt and have the main power switch, which is you can feel tactily the difference between these two switches, so it's not like you're gonna mistake which one you're holding. I'd like to have this one centered in the skirt and this one off to the right or left side. Probably the side that matches here, where the connector for it is. And yeah, we're getting close to being in business. Yeah, so I guess consider this almost like a part 2 to the previous video where I talked about wiring the relay. This was the test of the relay.